Today we're talking about M&V. I've got two guys with me, Brian and Marco. So they both are, I would say, in charge of M&V. Marco, I think there's 3 M&V leaders in Honeywell, and Marco is one of them. He has the East Coast. But I'd prefer if these guys introduce themselves. So Brian, I know you didn't know this was coming, but can you give a quick, like, 1 minute or 30-second bio of who you are and your experience and why maybe people should listen to you?
You want me to talk for 30 seconds about anything? Really?
Well, that's about 10 seconds are up.
Yeah, really. Oh, no. Good afternoon or morning, wherever you are. My name is Brian Klippinger. I've been in the energy business since, I guess, 97. So I've been around a couple companies, but my prime focus has been M&V for the last 20 years. So I don't know how I got kind of wrangled into this, but fell into it, and actually I really, really enjoy what I do every day. So.
Okay, and you are, how many people you have working with you, and what do you do and for who? Oh, I guess it says.
Thank you. I'm with Energy Systems Group. I'm the director of measurement and verification, and I think we're growing so fast. I think I've got 27 people now on my team.
Okay.
So.
Okay. Marco, you're up.
Hi, and good morning, good afternoon, wherever you are. I'm Marco Clerx. I'm with Honeywell with the M&V Group. Previous to that, I had worked at various consulting firms, worked at University of California, Riverside in the energy business, probably back to late 70s, 80s, including like doing wind mapping in California before all those windmills were there. Now I'm with Honeywell doing M&V. We have about 30 odd people on our team, crossing over from Canada through the US. In my specific portfolio, I'm handling the East Coast, and I've been at Honeywell for about 27 years. So.
All right, that's good. That's good. Yeah. All right. So these are the topics that I'm hoping we're going to cover. Doesn't mean we will, but we're going to try. So I'd like to start with the first one, and I guess, yeah, how about we'll always start with Brian and then go to Marco afterwards. Keep it simple so we don't all interrupt each other. So a few webinars ago, we talked about, John Chandra was here, talked about Bayesian Analysis, which was really, I thought, pretty amazing. And we've had Steve Cromer on a few times, and he's talked about, he had several ideas that were pretty intriguing as well. And Brian, one of the reasons we're having this webinar here, or one of the reasons Brian's here, is he wanted to respond to Cromer, and this was before John Chandra showed up. And so I wanted to hear what's your take on this whole thing?
It's pretty simple. I think we're trying to make things way too complex. There are times when you need a complex M&V plan to make to verify and make sure that it's an accurate assessment of the savings. But depending on the customer that you're dealing with, I think we're just getting way too, we're thinking way in as an academic versus what is really needed. I think we've forgotten what performance contracting is, and it's a mechanism to get stuff. It's a mechanism to pay for things that you can't do in other ways. And here in the US, we have a lot of legislation and statutes that allow us to do this. And I think, there is a mechanism that needs to be followed, but I think we're just trying to make it way too complex. And
wait, you say we, who's we?
I think industry is. I think there's a lot of consultants out there that, IPMVP it's a toolbox. I think of it as, we need to use the right tool, on the right application. And I just think that it can be done very well simply, or it can be done very bad in a very complex way. And I think we just need to refocus on what we're doing and what we're trying to get out of, measurement and verification for what we do.
Okay, so you're saying basically look at context. What are we after? What do we want, rather than get lost in the methods, which is what people do. They get lost in the methods.
Yep.
What do you got, Marco?
Well, I know you want us to be point counterpoint. I feel like
No, you don't have to be.
I feel
No,
like
no.
I feel like I'm in Saturday Night Live. So, Gene. So regarding like Bayesian, you had that slide, Bayesian, Monte Carlo stuff. Look, I break up M&V into technical, financial, contractual, and relational. When it comes to the technical part, I don't mind somebody like IPMVP investigating different statistical methods to help us, because in option C, which most of my contracts have option C in there, we use different regression techniques. So I don't mind people segmenting that part of the work. My takeaway on this Bayesian frequentist type thing is, I don't care about all the details because I don't have that much time. Just give me a number and an explanation that I can use. And if I have two people arguing about this is the number from the frequentist approach and this number is from the Bayesian approach, I'm just gonna take both numbers, average them, and that's what I'm going with. So I agree that things are getting, well, they get complex if we try to bring this up in front of our customers, because a customer can be a school board, and I'm not going to go into statistics in front of them. That's not really what they're interested in.
Yeah.
So I think it has its place. It just can't take over the whole conversation.
Speaking of complexity and all, uncertainty. So I don't remember what the IPMVP or core concept says about that, but I think they say that you should say what uncertainty is associated with your savings number, right? The whole thing of I'm 68% sure you saved maybe 85% within this number here, 100,000 therms or something like that. Brian, what do you think of all that? I mean, is that useful to ESCOs, do you think, in general? Or, I mean, before you answer, I just want to say, Marco and Brian aren't speaking as representing their companies. They're speaking as just people, okay? People who've been doing this for a long time. So this isn't the company line you're going to hear from either of these guys. They're just telling you.
Thank you for saying that, because I've written down my disclaimer and I forgot to say it. Nothing I say, expressed or implied, represents Honeywell. I'm just on my own, with my own opinions.
Agreed. Here. Otherwise, I may not have a job after this webinar.
That's right. That's
exactly.
Right. That's right.
Okay, John, to follow up what you said, you can't even say what you were trying to say. That's how it's like you're an expert in the field and you're trying to explain this to a group of people who do this for a living, and you have difficulty actually saying it. That's exactly my point. I think inside, when we're developing projects as engineers, we need to know what certainty is. And the reason why, we need to know how we're going to, no ESCO is going to go out and guarantee 100% of the savings that they calculate. Well, they may, actually. Depends on how hard they want to go after that work, but there's a risk associated with that. And folks like Marco and I, we're balancing a portfolio of risk. That's what we do. We're the risk mitigation team for an ESCO. And what you're trying to say is, yes, we need to have that certainty, because we need to be able to prove that, yes, we're going to make the savings. And we want to push, or me, the M&V world is, or the ESCO world in general is everything from an extreme capitalist, that's all they are is, about money, to all the way to, environmentalists, it's a tree hugger, and everybody in between. Some things are real, some things aren't. Our idea is to make the largest project we can, mitigate the risk as an organization, and give the customer what they want. And then at the end of it, I do have to write a guarantee that if we don't make those savings, if we don't make those numbers, I write a check. So but it's a balancing of the portfolio of how we do that. So the uncertainty that applies, I think that's backroom stuff that we do as an organization in how we assess a project.
Okay. Right. So it's, as Marco said, it's maybe not something a school board, we'll let Marco say it himself, but it may not be something a client is interested in because they're not statisticians, but it might be very useful to your organization. What do you got, Marco?
Well, in terms of the uncertainty, there's a difference between risk and dread. So, you dread something, it's more about some emotional feeling. We in M&V, when we talk about IP&VP, we put uncertainty in terms of statistics. And, you guys are reading the book Noise and stuff. You get it that people just aren't really good at having a gut feel for statistics. So I forgot which way the ASHRAE 14 standard says it. If I tell the customer I'm 68% precision with 50% confidence, that's not very confident boosting. And most of the financial people are pretty risk averse. They just want to hear you say, yes, no, you're going to make it. So when it comes to uncertainty, our team is probably, we're probably more concerned about assumptions and limitations that are made in the projection of savings, and that we know what those limitations are, what those assumptions are. Sometimes we add complexity by trying to work from first principles to understand what assumptions are made in a black box. So our in terms of our understanding of managing that uncertainty, it's things like assumptions that people make and whether or not they will hold over time.
That's uncertainty in the IGA process, but the ASHRAE 14 and core concepts and all that, they talk about uncertainty of the model itself. How good is that regression model? How much uncertainty is associated with the regression model because it's not perfect? That's different, right?
It is, but your starting point is the development of that baseline, right? And you might use findings in the IGA to modify that baseline. So you might already be starting with assumptions right there. So for example, I get a bunch of utility bills. How much of it is estimated? That's not necessarily something that's a calculated percent, precision or whatever, but it is something that you would keep in mind yourself to know how get I hate to say it, but a gut feel for the, how accurate this is. So as far as certainty, we're pretty comfortable with, what we get out of the different tools, the CV, RMSE, and the, R squared, the T-stat on the independent variables, and we leave it at that, and we don't go into much more depth than that because it's, again, something not the customers. And I have, like Brian, we have two sets of customers, our internal folks, financial people, and the external people, customers. So
okay, I want to take it the other direction. So I've seen M&V plans, or not M&V plans, I've seen M&V reports that are nearly identical year after year because they measure stuff. Let's say they had a lighting retrofit, but they also did those things, change package units, put in controls, whatever, but they measured a lot of stuff first year, right after the retrofit, post-installation, I guess. And then they made a report. And then but in the M&V plan, it says, look, the same is going to be the same every year. We're not going to measure anything for the next 20 years. The report's the same numbers, except for maybe there's an escalation in utility rates. That's not really providing much value, I don't think. And that's where, and ESCOs do that. I don't know which or how many or how often, but and maybe the clients wants it that way. I don't know. But what do you have any opinion on that, Brian?
Yeah, I think there's two issues that you're addressing there. One is M&V as a compliance tool, and the other is M&V as a value or a value add. when we do a performance contract, we have to follow, like I said, a legislation or a statute or FEMP or whoever we're following that guideline of that what we have to do determines the reporting throughout the term. And like if it's a simple project, going back to, you know, simple versus complex, if it's a simple project, yeah, the report probably isn't going to change. If it's lighting with some controls and, or, you know, lighting with some building envelope or whatever it is, and it's option A, and we have a valid way of doing it, a pre and post measurement, you know, the technology is good. We still want to do, you know, the annual site visits or quarterly or whatever that is set up, depending on the size and scale of the project. But that's a compliance thing. You know, we as engineers, we as a partner to these customers, we should be trying to add value to that. So the point of, you know, having a report that says something versus what actually gets done, I think are two different things. Quickly, I've got a story, and I tell everybody this story because it's kind of perfect for what we just said. I had a college that that I took over when I first started with another ESCO, and I made this brilliant report that was colorful and graphs and all this kind of stuff. The facility director just freaking loved it. You know, he was showing it to his VPs and doing everything. Well, as things went along, I got promoted and I brought someone else in who's really technical that could actually go out and look at the HVAC system and tell them when it's not working and stuff like that. So he went that approach. You know who that customer liked? Me, because I gave him this pretty report. It was worthless. It was looking backwards in time of what was going on. Well, the person that followed me was actually trying to help them.
Right.
And so it's knowing your customer, knowing what's going on, but it's that compliance versus value and figuring out how you can do both under a set of cost structure. Because we don't want to pay for M&V when it takes away from the project.
Yeah, the customers don't want to, yeah.
Yeah.
What do you got, Marco?
All right, so your thing about, you know, and it's typically option A M&V plans, and they say, they look like they repeat every year because they're using the determination of savings from the end of install, and then after that, they're probably just monetizing those same things. If you're looking at that only as your value add, I say you're looking at the wrong thing. Because in alignment with what Brian just said, you know, you have these M&V workshops, you show them the costs of M&V, the balance of the price, the value, and the risk, and often the customer ends up choosing, you know, like an option A because they don't want to pay more. In terms of the reporting, even if it's a repeated energy but with a different monetization, you are supporting the customer in addressing their constituents, because many customers don't want to be made bad. They want the nice looking report like Brian was mentioning, because it shows their constituents that they made the right decision 3 or 4 years ago. They, in some ways, the customer, don't want uncertainties showing up every year in front of their constituents. And so they, you know, many times they find that acceptable. But, you know, if you're going to look at an M&V plan or a report that's repeating every year, look for what Brian mentioned that the second guy did, the technical. So I suggest you put in a site visit report to do the value add. So, you know, you go out there, check the potential to save. Is the ECM still installed, set up, running as intended? You know, maybe you're still monitoring equipment performance over time, but remotely, but not calculating the savings, but just telling them if something's degrading. If you do site visits, you can find additional savings. You can monitor their behavior. It helps you put yourself in a consultative position with the customer. And my experience is, if the report really has no value add, the customer is going to cancel within, you know, 2 years or so. So it's
Okay, good. I want to move on to the next topic, and that's solar. How do you handle you have solar in your projects. You both do. So
Yep.
you guys are not among us three. I actually went over this agenda with these folks beforehand. So, and they both told me they do solar projects in addition to energy efficiency. So Brian, tell me, how do you handle solar? I mean, yeah, I don't, yeah, can you explain that?
Yeah, it's an evolving ECM, because solar was that eye-catching ECM that you always wanted to put in every, especially, Marco brought up school projects, put that solar panel on the roof. Everyone gets to see it. We just did a project where we did all this stuff, but we got to see the solar panel. That was the cool thing. Then, the subsidies started coming in, and those solar projects started getting bigger, bigger, and bigger. And at first is, we would do a model and we would tell you that this is what it's going to be. And that's what happened. It was almost like an option A where, yeah, we kind of left it alone. That was years ago. Now, customers have been burnt on solar projects to the point where, they think they're just a boiler or some other piece of equipment that you install and never have to do anything with. And they're not. They're very complex. They have lots of moving parts, inverters, and they get dirty and snow load, and things break on them so they don't tilt properly. So now customers are really focusing on us where they want to see the meter. They want to see how much input is being made by that solar field. It's a huge risk to the ESCO because we're kind of guaranteeing the sun's going to shine.
That's right.
And that's, when you put that boundary around a ECM of the things that you can control and the things that you can't, solar is one of those that you want to stay away from. Unfortunately, we're being driven, especially by our federal customers, that they want to see what the KW and KWH is coming out of that field, and they want that meter data. They don't want some model that we predicted was going to happen.
So just a quick response, and that is, let's say it's a 20-year project. You're going to have your years with more sun than usual and your years with less sun than usual, and it's going to even out over time anyway. So it doesn't matter if you have a bad year. I know you have an answer to this because we spoke about this before. Give me your answer.
Well, Marco's got the same answer as me, is no, they're not going to balance out, because typically we have to, it's a single year. We can't carry over savings, or, we don't have the option of, oh, we were bad last year, but we were good this year, so we're good. It's a year by year typically with these projects. It's a real risk because the sun doesn't shine equally. The helioscope, the PV Syst, all those programs are looking at normalized data over a 30-year period. So it's an assignment of risk at that point in time if you want to do it at the meter. We do projects where we just say, yeah, it's going to put out 5 kW and, we're good to go. But that's not exactly what happens. A lot of the cases is we are looking at the meter data. Sometimes we normalize it, sometimes we don't. Depends on the complexity of the customer and what they're requiring. But now you start talking, going back to what Marco said earlier, is talking to the customer. You need to actually have a good M&V workshop where you're talking about the assessment of risk. Do you want to have the risk on the customer? Well, then you normalize it. You just say, yeah, the output is the output, or is it on the ESCO where it's a true meter? And it gets really interesting because solar drives a lot of projects now because it is very, there's a lot of money in solar right now. But the thing is, I've been burnt both ways, where, the solar, once you get so much of a portfolio of solar, you realize all the things that can go bad. And
you got Mark. Oh, I'm sorry.
No, and that's a problem. So I didn't really answer exactly what you said, John, but those are the complexities of dealing with solar.
You did answer it. From year to year, you may be short 1 year, you got to write a check. The next year you're flush, but you don't get your money back.
Yeah.
Marco, solar.
Well, so got to differentiate between a PPA and a solar for a guarantee. It's going to be different. So let's just talk about providing solar under a ESPC energy guarantee. I would never do one that's not normalized. So I was actually kind of surprised at that. If we have, okay, since it's supposed to be my opinion, it's going to be the ESCO. I would always take the helioscope and look at what, the insulation tables that it provides, global horizontal insulation or plane of array, and I use that as my normalization. And I would always compare for that specific month, what was our anticipated output, at certain amount of solar insulation in, and I would compare that to whatever the solar insulation is for the current year, which means I'm always wanting to have a data acquisition system to measure that. And I would normalize the output to the model that we had. So if they had a lot less solar insulation, I would either normalize the target or normalize the production to account for the difference in solar insulation between the current year and our model.
I want to interrupt and see, because I don't think I completely understand. Let's say you put in a chiller instead. Forget solar. Let's talk about a chiller. And it's in Phoenix. For some reason, one summer, they don't have a summer in Phoenix, and the high temperature for the whole year is 80 degrees, not 110, and it's really cool. Well, if you're an ESCO and you're using, option C, M&V and normalizing for weather, you'd end up with very little savings. What's your baseline? Well, it's a lot less than usual because there's a lot less cooling degree days. What is your actual? Well, it's also less because there was less cooling, and your savings will be less because you were saving a percentage of the cooling, and there's a lesser amount of cooling, therefore you're saving less. So it's something that some people don't think about, or at least people are relatively new to the business, that even if you're normalizing for weather, there's still risk there, and you have, weird weather, you end up not meeting your savings targets. Now, in your case, though, I would think that if it was a really cloudy summer, then you would end up with, less actual solar production, and your normalized would be less. So you still end up losing, just like in the chiller example in Phoenix, right?
You're only going to lose if your efficiency of output versus input is less than what you had projected or guaranteed. I mean, that's what you're striving for, is to get to the point where for every month, and every month changes because of the angle of the sun. You want your efficiency of output versus input to be equal to or better than the model, less contingency for the guarantee. So that's what you're driving at. And in your example, that's to add complexity. The example you're talking about sort of is whether relative savings or absolute savings, right? Because you may normalize it, and even normalization based on a regression, you're not getting as much adjustment as you thought, but the customer in whole is using less than they had before. So that's when I say contractual and relational. You got to look at your contract to see if you're covered, and you got to have a good relationship with the customer to overcome some of those nuances. But as far as solar, if I use the model as the baseline, then I'm usually adjusting the baseline. If I'm going to say that the baseline is 0 production, but I still use the input irradiance as my normalization, then I will normalize the production output. So the Marco ESCO is still going to try to negotiate the contract in a manner that I can normalize this. The other piece of information I would add is, I guess I'm okay to say certain things, but shit happens, including birds over solar panels, which I've had birds dropping seashells, trying to break them open. Things oddly happen on solar panels that you should think about. Production meters go down, so it might be good to monitor the inverters as well as the production meter. So It seems like a simple ECM, and it typically is for the small systems, but when you get into really large systems, you'll find out all the, there's quite a few issues that can happen.
It does seem simple.
I want to say one thing, John, that there's nothing simple about PV anymore. Unless it's like a little 5 kW system that, you know, is the art on the wall, because there's so many things that can go wrong. It's funny listening to Marco say about the normalization, how like that's the key problem with solar now. That's actually the smallest thing that's going on with solar, I think. One, you have to start off with what model you're using with helioscope. It's set on P50, a probability of 50 on, that's what you do without changing anything. And if you're guaranteeing something, going back to what you said, that's only gonna, so every year there's only a 50% probability in layman's terms that it's gonna happen. Well,
yeah.
So there's a P90 and a P99 probability as well in all the programs. You've got to figure out what you're willing to risk because of that. But the other thing is the operation of it. And Marco alluded to it, that, you know, bird droppings and stuff. You've got people that mow the yard that throw rocks, you know, from the lawnmower at it. You've got heat. You've got inverters that are sitting out in the sun in the desert of Arizona. You've got, you know, hurricanes in Florida. You've got all this stuff that impacts this piece of equipment sitting out in the weather. You know, we've had projects in the Rockies where they get a lot of snow. Well, you know, you know, the salespeople for the solar companies, they love to tell you that, well, the tilt will, you know, when they tilt, the snow falls off of it. Well, that's not always true. So the pyranometer that's telling you that you've got good savings because you've got good sun, but the solar panels are all filled with snow. So there's lots of things that can happen just from weather, but then from an O&M standpoint, an operation and maintenance of it, that's a real big issue. And that's why the federal government, especially on DoD sites now, is insisting on looking at the meter of the data coming out of it, because they've been burnt for 10 years.
I buy that. I buy that. Okay, I'm going to change topics. So we had a company on a while back called, their name was Redaptive, and they do energy projects. They're not really on your ESCO model. I don't know if they guarantee or not, but the way they do M&V is they'll put a meter on a circuit, not a circuit, on a circuit board, and they will, you know, put CTs on every circuit or on most of them, and so they're metering tons and tons of different points for electricity, for power. Have you guys tried that? Have you thought about using it? Have you tried it? And what's your experience with it? If you have, Brian?
You know, going back to that complexity thing, that, you know, Rube Goldberg mechanism, you know, yeah, you get a lot of data, you get a lot of analytics on that. But you mentioned one word that is key to me is electric. I'm in the Midwest. Marco's in the Northeast. We have a lot of things other than electric from an energy standpoint.
Yeah, that's right.
So we've got steam, we've got natural gas, we've got diesel, we've got propane. So you've got all these other things. You're talking about one point. I think it's good from an analysis standpoint. Would I guarantee things based on it? Again, you're getting a lot of information. Metering that circuit tells you a lot if it works. But, you know, sometimes we have glitches in the IT. Oh, by the way, now I can't talk to it because the protocols with the school districts or the customer. Now I actually have to go to the site to get that information and download it. There's so many issues that are popping up with that it becomes very complex. And I'm not saying it's not a valuable add. I'm saying that you're only looking at maybe in our worlds, maybe 30% of the utility bill. That's not a lot, you know, comparative to other things that you can do. Is it a point? Is it, you know, a thumbtack that you can put to figure out things? Yep. I like it a lot from a development standpoint. From an M&V standpoint, they haven't sold me on it yet.
Okay.
I'm not sure it's real.
Marco, what do you got?
Well, oddly enough, I had one of the same points. Does not address M&V monitoring of gas, water, propane, oil, wood chips. And the funny thing is, you're going to ask us later about changes in the industry and AI, but it's a lot of the new stuff coming out is all focused on electricity. But as far as monitoring breaker panels, this is, as a concept and implementation, it's not new. I mean, we did it in the 1980s with synergistic panels out of Texas A&M. 1990s, like the Boston State Transportation Building was monitored. What's new, I think, lately is the hardware is cheaper to overcome the IT problems. The cellular communication modules, so they're using cellular instead of tying into the customer's network, which also helps with cybersecurity. And the installations are so simple that, you know, it's cheaper for the vendor, because in many cases, a vendor can just ask the customer to use their own electrician to install this. So they're getting a little smarter about doing this. What's really new is the devices have self-recognition of their own device addresses. And actually, that's not new at all, because, you know, BMS systems have been doing this. The really new thing that I think has been added is automatic identification of the load type from the electrical load signal. So they're using like electrical signal processing to say, you labeled this as a lighting load, but that can't be right because it has a signature of inrush current, or, you know, it looks like a motor, and so it'll tell you that. That's probably the new item. And yeah, we can talk about it more when we get to changes in the industry, but, you know, it's getting pushed because in some cases, I think the market is not the typical mush market. They're going to industrials with shorter payback times, and, you know, people on staff are more detail oriented than the typical mush market, I would say.
So okay, yeah, that was interesting. Tell me about interval data. Brian, do you guys use it, or and what value do you see in interval data for ESCO?
So during the development period, we use it a lot because it tells you a lot about how the equipment's running and that sort of thing. From a M&V standpoint or post-install situation, when we're doing power generation or some type of electrical grid modification, we use a lot of the interval data. We don't use a lot of interval data for our post-project measurement verification. One, it's a lot of data, and if we're doing things right, you know, we should be able to see those sorts of things, but it comes down to time. Until, you know, we're going to talk about the AI and stuff, but right now dealing with, you know, the metadata is difficult. And interval data, depending on how it is, you have to really focus your effort on, okay, is it worth it? You know, in the complexity of the project, what are you doing? Is it controls? Is it lighting? Is it, you know, building envelope? You know, what, you know, HVAC, whatever that complexity of the project, does interval data really do anything for you? Sometimes it doesn't. Sometimes it's a nice tool to have when things go wrong. So we use it more of an analysis when we see something going wrong than a something that we use to verify savings. Now, you know, like when we're generating electricity, we have to, because, you know, we're matching whatever's on the grid and from the utility. So typically it's an analysis tool and not from a verification standpoint for us.
A measurement. Yeah. What do you got, Marco?
Well, so it just occurred to me just now that when you said interval data, everybody probably just assumes you're talking about interval data from the utility.
That's what I was thinking. That's what I was implying.
And that was my original thought too. And as much as I'm supposed to disagree with Brian, I have to say we sort of the similar in terms of if I split this between, is it used in solution development before installation and is it used in M&V? It's probably 90% for projection modeling, especially for cogen, combined heat and power, thermal storage, and microgrid. That's when we would really look at the interval data. But for regular M&V, not typically, the cost isn't there to support that. But, you know, M&V jobs where we have fault detection and diagnostics, then we're getting interval data from sub-meters and BMS systems, not necessarily electrical. And, you know, that has to be small time-stamped data. So I think that the whole talk about interval data is really driven by the smart grid being able to provide it and utilities talking about it in their programs.
Yeah, I think so too. I think so too. I mean, I think it's like Brian said, it's useful for modifications, for baseline modifications, or what you call them, non-routine events.
Yeah.
To identify, you know, okay, we have an increase in usage. When's it happening? Oh, it's happening off peak. It's happening between these hours, only on weekdays. I wonder what it is. And that's useful. You can use that to troubleshoot why you have this increase in usage or decrease. And then once you can identify what it is, then you can deal with it. You know, we're not going to, because of time, we're not going to be able to talk about it, but it's too bad we didn't talk about the NRE manual, but maybe another time. All right, so let's see, Marco, you had that slide. Do you want to talk about that? Because
Sure.
I forgot about that. Can you see it?
Yeah, I see it.
Okay, can you explain what this is?
So, yeah, I actually had an opportunity to give a talk at a roundtable for AEE New England. It was held at MIT, and it was about, you know, M&V. It was covered to M&V, but my topic was, you know, M&V from a business point of view. And since this was part of our discussion today was about complexity, this was my mind map. So if you're running a business to do M&V, then, you know, at the customer level on projects, you're talking about relational, financial, contractual, or I call it agreements here, and technical. And I mind mapped out, you know, all the different sub events that happen with each of these. But if you're working like for a corporation, you know, or you have shareholders to answer to, you got the Sarbanes-Oxley type responsibilities that you're being held to. You're being managed on, you know, revenue, risk, and cost. And then in some cases, you know, a large business with a financial controller may look at the M&V team above and beyond what they're doing on the performance contract, and they may come to you and say, hey, we want you to also look at any operational issues like unplanned future cost, operational guarantee issues. We need you to be in sync with our legal team on procurement concerns and any future interpretation that the contract is valid, and then, you know, corporate fiduciary responsibility to shareholders and customers. And again, like I mentioned, the SOX responsibilities. So if somebody said, you know, M&V is not complex, well, it depends on whether you're talking about a single project, single customer, or you're talking about running a business. Then you can get into a lot of detail. So this was just a support for there is some complexity to M&V, as you know, in terms of running that as a business.
Good, appreciate it. All right, let's get to the last topic, which is, well, I'm going to combine them, AI and changes to the industry. Brian, what do you see coming, and how is AI going to integrate with what we do or replace what we do?
Well, I think that AI is again going to add a data point and will do some things. Some of that, there's some crazy things going on right now where I think it's doing some good, where you're doing a lot of analysis trying to figure things out, especially on complex, controls and that sort of thing, trying to figure out what's going on. So I think it will be a value add tool that we can use to then go back to the customer and say things. So I'm excited about it, but I'm also I'm a pessimist when it comes to it, because they've been saying this for years that technologies are going to take over what we do, and I haven't seen it yet. The interval data, the redactive, all that stuff. Marco said it. It is a price point that's coming down, and I think AI will help that. Is it going to get rid of people? No, I don't see it yet. I don't see how that is. Maybe I'm just old and craggy, but I don't see that working yet. I want to see how that's going to do. The other thing is, and it all comes down to the capitalists in us all. There's not enough money in it for the people that are developing this stuff.
How's that? I don't understand that.
So you have a lot of the ESCOs, a lot of the control companies, the Honeywells, the Johnson Controls. They're all trying to implement AI into making their product better. Who else is doing that? You don't see Google doing this for the HVAC world. You don't see, they started that back in the late 2000 or late like 2010, 2012. They kind of stepped their foot in. The market share isn't big enough. We're only talking about, our world is about $5 billion last year. I don't think that's a big enough world for the big money to come in from an AI standpoint and make this stuff work. Like I said, maybe I'm the pessimist on it, but I just don't see that as being the case. I want it to, because I want more data. I'm an engineer. I want to be able to see stuff. I just don't know whether it's going to happen or not.
All right. And there's a lot of companies that are not, part of Google that are AI controls companies that, I don't know if they're really using AI, but they say they do. But
I want to see it, John. I'm not optimistic that it's actually going to make a huge difference yet.
Yeah.
They got to show me.
Yeah, just a brief thing. ChatGPT put out version 4 yesterday. And some guy was saying that, he wrote a book in an hour. He didn't write a book, it did. And it's crazy what it's doing. It's writing code, it's writing add-ons. It's pretty amazing.
I want to add one thing before Marco, because I want to get this in, is you're taking a very complex algorithms and all this AI knowledge, and you're trying to force it on a Honeywell controller that was built in 1990 that customers are still using. Mm-hmm. And that's a testament to Honeywell that controller is actually still working, but it can't do all the stuff that the AI is telling it to do. So the whole system has to work all as one. So you can't put in this magical device and make everything out in the field work.
Well, right. If the temperature sensors are wrong or the valves aren't stroking.
It's not commissioned correctly. It's not working right. It's not going to work.
Marco.
Well, so AI, machine learning, it's coming whether we like it or not. And I know you just said that ChatGPT wrote a whole book, but your own example in the thing I sent you, you'll see that it doesn't mean that it's right.
No, it is.
And
that's right.
I'm old enough that I remember when PCs came out, and there was the age of whatever gigo, whatever you want to call it, garbage in, garbage out. I think we're at that age again where everybody's going to tout this stuff, and yeah, it's powerful, but it can be powerfully correct or powerfully wrong. And it's hard for us to know what, when it is, because I don't see tests being developed to, test the accuracy. And we already now are starting to hear about the bias that's built into training of these systems. Some of that bias is really tricky to try to figure out whether or not it's really biased or not. So who's out there to define this garbage? And what is garbage? When I say garbage in, garbage out, who's going to define what's garbage?
But when it comes to AI, and I mean, AI will probably be one of your ECMs in the future, and that you can measure the savings from that.
Can measure what?
You can measure the savings. You just, attach AI to your control system, and then we have before and we have after. You can put it in metrics or option C, and you can see, yeah, it saved energy. I don't know what it does. I don't care. It's garbage, but it works. And
right,
that
you can do that.
But what about M&V and M&V and AI? How's that? Any ideas on that?
Well, there's a couple. So all AI and all machine learning are not the same. People think like it's going to be, it's going to think like a brain. Well, that might be a neural network. That's not like a logistic or regular regression type of machine learning. So I think it's going to be used for systems that are going to try to optimize. It's going to be used in tools to try to optimize the existing systems out there. But as Brian alluded to, that optimization is going to be limited by the number of sensors that are existing and the flexibility and robustness of the existing infrastructure.
Yes.
If it's not flexible, you're not going to be able to optimize that much. So though, that's some of the considerations that are over and above the ability to have this machine learning help you. But yeah, no, I think it's going to come out there. I think even if you don't see it first in the ESCO world, you're going to see it in the utility world because they're using large data sets. And when it comes to large data sets, that's where it excels, as opposed to trying to train on, 12 months of one building and work there.
12 points, right? What can you tell from that?
12 points. So.
No, and that's going back to my point on the money, John. That's, grid optimization, those sorts of things. That's where it's going to really have an impact.
Mm-hmm.
Doing our jobs and doing M&V, I, in a way, I wish it would be, because I can't find people. Hey, if there's good engineers out there right now that are looking, give me a call, because
I knew that was coming.
People.
Marco probably wants people too. So yes, I knew.
But I get them first. I said it first, so.
I did want to mention that I would advise all M&V people now to start, maybe at least one level, subscribe to somebody like Bernard Marr on LinkedIn to see his, discussions of new things in AI and machine learning. There's also, you can sign up on Microsoft.com for learn.microsoft.com. They have classes on understanding machine learning, and you got to get used to this stuff so that you can at least start asking the right questions and talk to them.
That's right.
And have you ever noticed that the two most mentioned platforms are like Microsoft Azure or Amazon AWS? It's like, who out there? How much diversity is there in actual control of these platforms running these regressions? I want to know that.
Pure mind control in the future, absolutely.
And the other thing is, the technology is way ahead of our regulation and way ahead of the old guys in government. We need, we need some people that understand this to help monitor it.
That's right. That's so true. Okay, we're running late, but any other, I'll start with you this time, Marco. Any other changes in M&V that you see, or in ESCO business besides AI?
Well, when fusion comes, I'm not sure we're all going to be in business. I don't know about efficiency, but AI will probably be applied to fault detection and diagnostics, and FDD will be used to help support ongoing persistence of savings in the performance period. That's where I see it being beneficial.
Okay. What do you see anything in the future, Brian?
Well, I know this is a hot topic of yours, John, and right now there's a battle between EVO and the utilities and the ESCOs, and where IPMVP is going and that sort of thing. I think that does have an impact on our future. I don't think it's as big a deal as maybe you do, because again, IPMVP is a toolbox. You apply it how you want, and as long as I'm not being required by legislation to do something, I'll make it what's best for myself and my customer. But I think right now there is some changes coming from that standpoint. The utilities, they have a lot more money than we do, because we spend all of our money with our customers.
Yeah.
We go do projects, not look at 40 different Targets or Walmarts. I think the energy engineering is going to be fun, I think, again, because they are going to have more tool sets. But from an M&V standpoint, I'm nervous that we don't have the staffing. I mean, where are these people going to come from? Because everyone is searching for people, but yet where are they going to come from again? So that's my biggest scare is manpower. Where are we going to get the young engineers to come into this industry and make it cool again?
Okay, so I'm going to keep running over. I know some folks will drop off, but I got a question. So one person asked, and I don't know the answer, so I want to hear, don't be an apologist for ESCOs, just be straight up honest here. So this person's saying, look, over the past 20 years or so, hasn't it been that the ESCOs are pretty much kind of recommending that you do the most stripped down M&V possible? Let's just go with option A, or stipulate as much as possible. Then you can get more stuff. I mean, I was told it's the other way around, where the clients were told, look, you can have more stuff. We can do these 3 extra buildings, or we can do a better M&V. What do you want? But this person is saying, and this person, I won't mention their name, but they've done plenty of performance contracts in the past. So they've worked with a lot of ESCOs. So what do you think of that comment or question? Why don't we start with you this time, Marco?
Well, so before I started working for an ESCO, I probably thought the same thing. Now working in this field for quite a while, customers really buy this either are, or they have a representative that's very financially savvy and want to cut costs really quite a bit, and that has affected M&V costing over the years. It's gotten tighter and tighter as customers realize that their budgets are limited, and they have to decide on whether to pay for more detailed M&V or instead get more energy saving capital equipment. And almost always the customer themselves will decide on more capital saving equipment. I have a skin in the game in terms of, I would like to have more M&V, because then I and my staff would be employed more. So I would towards more M&V, but I'm sorry, that's not what we're getting from customers.
Yeah.
We're not driven by the ESCO.
That's hilarious.
By the M&V team.
Yeah. Well, the thing about it, John, is we're in a very mature market from a performance contracting. If you talk, I know you go across the world and see things differently, but maybe I'm looking at it through my red, white, and blue glasses. But I've seen a lot of stuff that's going on in Europe, and some of the EVO calls that are going on right now, talking about the performance contracting, how they're doing it. They're very basic compared to what we're doing or what we've done here, because we've done it longer. And going back to Marco's comment, is people know what they're getting to the most part. Now, there are some shady deals out there. I mean, there's a reason why, option A and option B used to be the smoke and mirrors. There's reasons why people say that, but the good, honest ESCOs and the people, going back to, Marco said it in the very first thing he said, was relationship. We have a very finite group of customers, and if you really want to tick one off, especially like a school district or a university, those people all go around and you lose one customer. No, you don't lose one, you lose 20 because they go and tell all their friends how bad you are.
That's right.
So M&V is important. Is it the critical piece of doing performance contracting? Sometimes it is, most of the time it's not. The value add that we can bring, that energy engineering that we bring to the table, that is extremely important because, you know, the day that we walk off the site, your savings start going away.
Yep.
They start eroding immediately as soon as you walk off the site because set points gets changed. You know, everything happens differently. And you're not there to tattle on the people that are doing it. So it's vital that we do what we want to do, regardless of whether we want more M&V work, you know, for us to keep us employed for, you know, 5 or 6 more years. But it's one of those things that it is important. It's important for the school districts or universities or federal government sites. The money doesn't just come from anywhere. You know, it's not a blank check. You have to pay the bills. And if you can't pay your energy bill, you have to go from somewhere other coffer to get it. So,
But you know what? That's when you say changes to the industry and the goals of AI, ML, I think to some extent, well, to a large extent, people in this industry or customers will want AI, machine learning to be the item that lets you have your cake and eat it too. It's going to be cheap M&V and automatic and tell you what you need to know. So, you know, and people are working on trying to build tools that, you know, will calculate savings.
You know, the answer might be that combining that redaptive approach and AI, put those together. You meter every electric circuit. I mean, I know electricity is only what you said, 30% of the energy use, but you meter every circuit and somehow connect that up to some AI engine and maybe, I don't know.
That's what's going to happen. The trick will be handling baseline adjustments.
Hence, you need the energy engineer. So we're never going away, John.
Here's a quick story from me. I mean, I know people didn't come to see me, but I'll tell it anyway. So when I started out at Johnson Controls, and I didn't really have anyone to teach me M&V. I just kind of made it up as I went. Basically, I read the NEMVP, the first IPMVP, and I kind of, yeah, I mean, there wasn't really anything to go on. There's nobody to tell me what to do. But anyway, at one point I had to do a non-routine adjustment or a baseline modification. And so I calculated up in Excel. I got a number. And then I thought, you know, but maybe I should do it this way. So I did it a different way and I got a different number. Of course, you calculate the same thing 2 ways, you get 2 numbers. And then I was left with the conundrum. It's like, well, let's see. If I pick this one, I'm cheating the customer. If I pick this one, I'm cheating the ESCO. Oh no. And it was like, that was the biggest curse, you know. It's like, I mean, if you pick an average of the two, then if you have some third-party consultant come by, they're going to be like, you can't do that. It's going to be based on sound engineering principles. You can't average these 2 approaches. Oh my God, what a disaster. But anyway, we should probably go. We're late. You guys, this was a great session. One person wrote in and said, what a great discussion. I feel like I'm sitting in on a really smart lunch table and listening in. Thank you.
Must have been the other 2 guys, I can say. So.
Yeah, the rest of them didn't say anything. Well, they haven't gotten, they didn't leave. So, oh wait, we got a new one. Oh, I got another note. Thank you. There you go. Guys, thanks for coming. This was a good session. I appreciate it. Bye.
Anytime, John. Anytime, Marco. Thanks, guys.
Brian. Bye, John.